Welcome back. Today's video will be a little bit of lathe maintenance. On the last video that I made, I struggled to hit my numbers on the threading, and I couldn't figure out why. First suspected that maybe there's some grit on my scale somewhere that was messing me around or giving me false readings. But it wasn't the case. It was a compound. These bolts started to strip on both ends, and that caused the compound to twist a little as I applied force, and I only noticed it afterwards. Now I've tried to unscrew them, and these things just turn up to a point and then they just spin around. So what I'm going to do now is going to put it in the hydraulic press and press the bolts out. These things are very soft. I've even put nuts on top of it to try and clamp the compound down. They just strip on the top half as well. So what I'm going to do is just press it out and then see what I can do to get a replacement bolt or make bolts for them. I've got a little plate here that's going to fit in between the dogs just to support it. Now what you must keep in mind that if you want to press a bolt out like this, that the holes line up so that when you press it through, that it doesn't damage the compound. Now if you look at it from this side, it's on a 54-degree angle, so you have to be mindful of where your bolt is in relation to your base. Easy as that. Now this is definitely not 10.9 or a 12.9 grade. You look at it, this shaft is stripped clean. Even the nuts doesn't have proper threads in it. I cannot get one of those bolts, so I've opted to make a nut or two nuts. Now this nuts needs to be made from round stock. I need to bring this 25mm rod down to 19 and cut two flats in it. Now the reason why I'm doing it here and not in a lathe is obvious. I don't have a compound, so I can't use the lathe. So I'm going to use the end mill instead. I've zeroed my spindle using the dial indicator, and I've centered the stock in the chuck, also using the dial indicator, and then zeroed my DRO. So I'm going to do my offsets and then start milling the OD. Then it has to be I don't know, about 14mm thick, so I'm going to bring it down to 20 just to give me a little bit of clearance, and then tap it afterwards. I'll just spot drill it and then put it back in the lathe and then drill it with the lathe, because I don't have clearance between the spindle and the machine to get a drill bit in there. Right. Okay, I must just make sure that I'm milling clockwise. Make sure I do a conventional cut. And I'm going to melt to opposite flats. I need to take 1.5 millimeter off on each side. You know what they say about clearance? I've got the millimeter underneath. Okay, I found center using my center finding pin. That's the reason why I drilled the center hole in the back. And then I'm going to drill it 6.8 for a 8 by 1.25 millimeter tap. Okay, I've got my two nuts bolted down to the 1 to 3 block. What I've done is I've gently touched down with my end mill on that 1 to 3 block and zeroed my DRO. And I'm going to use the 1 to 3 blocks bottom or surface as a reference for the thickness of the nuts. So I need to mill this down to 6.5 millimeters thick because that's the thickest diameter the compound base can handle, not diameter thickness. So yeah, let me start. I'm going to start with very light cuts because I don't want these nuts to unscrew themselves. I think that's close enough. Here's a nut. The opening is just big enough for the nut to go through. And I've made the flats extra tight. Don't want a lot of wiggle in there. I'm using 8.8 grade bolts. This is the right one, 8.8. I would prefer to use a 10.9 or a 12.9 grade, but I don't have any stock. The rotate's easy enough when it's loosened, so I'm happy with that. That wiggle that you're hearing there, it's because the component is not bolted to the table yet. And that's a lot better. Alright, job is done. Compound is operational again. Hope you enjoyed. Until next time.